it in case if anybody wanna see watch it later. So no, people are there are only 4 students right now. So basically, guys, as I told you in the previous lesson, yeah, we are going to start quadratic equations. Yeah, this is a topic that is, as I mentioned before, the second, arguably most important topic in the whole SAT math section. Now, what it is actually is it's just an equations, equations, functions that are functions, equations that have usually two answers. Yeah, and they have their own properties, they have their own rules. They are simply, equations basically. And when you graph them, they will represent something on the Desmos and such things. So quadratic equations usually look like this: f of x equals f of x equals x squared plus bx plus c, right? And you will have some numbers for a and b or and c. And if you plug in and use some randoms, let's say a is equal to 3, b is equal to 4, and c is equal to 5, you can see a graph of this function. Now, because there are two answers, it's not just a line like this, right? As in the simple equations. X squared, whenever you say x squared, it is a usually quadratic function equation. That means there are two answers to the x, highly likely. Not always, but usually there are two answers for the x, and the graph is something like this, which we call it parabola, right? It can be something like this, or it might also be something different like this, right? So it will be up or down like this. But basically, it's something that looks like uh, what can we say? It looks like this basically. It has a low point. This is the minimal point, the minimum point of this whole thing, and it might have maximum point depending on how it is graphed. Right? We will talk about the maximum things, minimum things later, but this is what a usual quadratic equation and the graph of it is. How it looks like how it looks like is represented in here. Now, usually we have questions based on these equations that ask you, let's say, let's plug in the numbers, right? So that we can have more space in here. Let's say 6. The questions usually ask, what is the solution to this equation? And usually it looks like this sometimes, like this. It will have 0 in here. I think you all know it from, I guess, high school. They have taught it many times. And they usually ask for the value of x or for the answers or the solutions of the x, not just one value or not just one solution, because there are usually two answers. Now, the questions can be solved most of the time on Desmos, and there might be hard ones, but still, if you understand the concepts, deeper, you can still solve them on Desmos. This topic is, 99% of questions can be solved on Desmos without any struggles, if you just know some of the rules and some of the tricks. Let's say you have a question like this. An equation is given like this, and you have to find solutions of the x. What you can do is you can just write it down. I just put this thing in here just so that you know do not it doesn't matter that much, but you can it is the real this is the real thing. But when you have a question like this and it's asking for the value of x, you can just look at the graphs. And yeah, I think it's not, yeah, something like this. Yeah, let's say this equation. You can just look at the graphs and the places at which the lines cross the x-axis, these two places, are the answers. So the first answer is negative 2.4305, and the second answer is 1.09717, right? Now, these are the values of x that would make this equation correct, right? You could have sometimes, like we had right now, no graphs like this. We just had no graphs, if you have noticed it. When I plugged in like this equation, there were no graphs. It means there are no answers to this equation, all right? When you see a graph, it is an answer. When you do not see a line that crosses the x-axis, it is not the answer. We can also have maybe, let's say, times like this, in which the answer is this for the x1 and the x2 is this. Now, this is the Desmos way of solving this question, all right? The other two ways, which I will explain right now, are kind of harder, but they are usually done on paper. You don't use Desmos for them, all right? Let me screenshot this and send it to the group. The paper ways are usually gonna take more time, and they might make you make mistakes, sometimes. So that's why you have to avoid them most of the time. But you just need to know how to solve it and how to do those things. Now, the first way is the paper way. If you want to solve it without Desmos, is factoring out. If you have something like this, let me show you from the book. Yeah, if you have something like this, x squared plus 5x minus 14 equals 0, you can factor this whole thing like this. I think you all know factoring. It's not important. Yes, even if you don't know, it doesn't make much of a difference. But if you have, let's say, this equation, you can factor out in your mind like this, and then calculate, equalize these x plus 7 to 0, and then equalize x minus 2 to 0, and then get the answers. So the first one is equal to -7, the second one is equal to 2. And if you even put it to Desmos, plus 5x minus 14 equals 0, was it like this? Yeah. You will still get the same answers. Yeah. -7 for the x1 and 2 for the x2. All right, these are the answers of x. And they just factored it out. They took the longer way of solving it and got the same answers. Now, the third way, this was the second way of solving it. The third way of solving these questions is using this quadratic formula, which is, I think, most of you know already, most of you are familiar with, right? It is, you have to, memorize this if you want to solve using this formula. Negative b plus minus square root of b squared minus 4ac divided by 2a. Now, here negative b is basically this number in the middle, right? So it will be -5, and then plus or minus, one of the answers is with plus, the second one is with minus. It will be square root of b squared, square root of negative square root of 5 squared, right? 5 squared minus 4ac minus 4 multiplied by a, which is 1 in here because there is no number, right? So no number means 1, hidden 1 in here, right? 1 is hidden here. And then multiplied by -14, right? Now you will divide it by 2a. 2 multiplied by a, which is 1 again. So the first answer is 2, which is what we got, right? And if you have noticed, we just used the plus sign in here. We haven't used the negative sign, right? So if we change this, if we use the negative sign, we get -7, the second answer, right? So the first way of if you use the plus sign, you will get the first answer. If you use the negative sign, you will get the second answer. But this is how you use the formula to solve these questions. I wouldn't recommend using the factoring method, nor would I recommend using the formula, because the easiest way to solve this question is just by clicking on Desmos, writing the whole thing down, and then looking at the graphs. Because I think, I believe, I am sure that Desmos does not make mistakes, while we humans can sometimes make mistakes, right? So we have to be sure, we have to be careful here. Now, let's look at some other examples of what type of questions we might get related to this topic. These are the easier ones that we are looking at first. For example, in here we can read here, one solution to the given equation can be written as like this, where n is a constant. What is the value of n? So we have solutions, and one of the solutions can be written in this form, and we have to find the value of n. If you have noticed, this is very similar to this in here. If you use the negative sign and this thing comes down to n, we can get something similar to that. Yeah, let's say we use the formula and try to solve the question. So 2x squared minus 10x plus 3 equals 0 plus 3 equals 0, right? And if we use 5 minus, yeah, we're gonna use the quadratic formula, which is 10. It's gonna make 10 minus square root of b squared. So 10, minus 10 squared minus 4 multiplied by 2 multiplied by 3, yeah, divided by 2 multiplied by 2, which is gonna give us this answer. And you know we are this 10 is this b in here. It was negative b, negative, negative b. These two negatives became a positive, so we just deleted it. Oh, and then we wrote down the whole formula. Now, what we got is the value of one of the answers. And if we equalize this answer to 5 minus uh, 5 minus square root of n divided by 2, we will get the answer of n, right? So these are two equal things, basically, because, this is the first part, this is the second part, but the whole thing is just divided by 2. This whole thing in here is divided by 2. Or the easiest way of solving it is just writing down 5 minus square root of n divided by 2, and then equalizing that value to these x values. So the first value is this thing. We can equalize it like this and get the answer again 19. So, the solution was equal to this. And we can see the solutions, what their real values are from here, these 2 points. So we are getting one of them and equalizing to the given expression, right? And we are getting the value of n. It's showing us there's 1 in here, but it is not something that's going to make the answer incorrect or it's going to change it. It's just, margin of error. And if we try to put the second solution in here, like this, it will show you 0, which is indicating that this is not the right answer, right? So the value of n is here 19. Yeah, they directly said that the solution can be written as like this. So we found the solution, the real value, and equalized that solution to this way, to this thing, so that we can find the n. And they are using the first way of solving it, which I showed, the formula, negative negative 10 plus negative plus minus this thing divided by 2, and they are dividing this whole value by 2 to get the answer. They are doing the same thing but in a longer way, right? So what I recommend is writing down this whole equation, finding the two answers and equalizing the answers one by one to this expression, so that you will find the value of n. Now, another Desmos trick you could use, very useful Desmos trick, is in here. Let me show you that trick. It's not, it is something that might trick you, might get you confused, but it is also a trick used by many people. So when you have some question like this in this exact form, these questions, this specific question is repetitive. It will be shown. It will be in most of the exams. I have seen this in my own exam. You can solve the question by either the formula way or the second way of finding the answers in here. The lines, and then equalizing that lines, the answers to the expression. Or you could use the write down the thing with tilde and x1, and then say to Desmos that there are two answers like these. The first one is this, which is given to us, and the second one is basically the opposite of the given signs. So we have written this first answer and then the second answer. All right, this is the rule. This is how you this is how the trick works. Basically, we are telling Desmos that there is this solution and there is this solution, and Desmos is going to solve us for the value of n. All right, so we have gone through three ways of solving this exact question, which is, this question is very repetitive, as I told you. So the first way, looking at the lines, equalizing the answers from these lines in here to this value. The second way is using the formula, which I would not recommend. And the third way is telling Desmos that there are two answers, but the second answer will have their sign. If it is negative here, it will be positive. If it is positive here, it will be negative. All right, we have to change them up to the opposite, so that it is how the formula works. It is how the trick works. This is the third way of solving it. So let me screenshot it and send it to the channel. Yeah, Desmos is very helpful in these types of questions, or overall on the SAT math section. 5 minus square root of n divided by 2. Guys, so far have you understood all the, all the tricks we are solving for? We are, learning all the things, all the formulas. Right. Now the third way is again using this formula, but I would not recommend. So just don't do it. Now, when you have a quadratic function in this form, x squared plus bx plus c equals 0, yeah, as I said, there are two answers. But there might be cases of multiple answers or one answer or one solution or one multiple solutions. And sometimes the questions ask you, what is the sum of solutions? Sum of solutions, right? Sum of solutions. So sum of solutions means uh, sum of solutions. What it means, yeah, just adding the solutions. So if you have the solutions -7 and negative, let's say the answers are to a random equation -7 and 5. The sum of solution is -7 plus 5. Yeah, two solutions, a and b. We have to add a plus b. All right, this is sum of solutions. Adding them. But when you're asked to find sum of solutions, there is a very easy formula that you can use to find the sum of solutions in any given equation in this form. And the formula is -b over a. So if you have this equation, you could just get -b, all right, -b, and divide it by a. And you will get the sum of solutions directly. Not one solution, not two solutions, but the sum of all solutions possible directly in here. For example, let's see an equation. Let's see an example. In this question, x squared plus 5x minus 14. Uh, oh, x squared plus 5x. We have two solutions, right? -7 and 2. If we want to find the sum of solutions, we will add them. It will be -5. Their sum of solutions is -5. And if we indeed divide -b in here, -5, which is divided by 1, which is hidden here, not given, it will still be -5. So the formula is indeed correct. Yeah, we are proving the formula that adding these answers will be indeed -5. So the formula is just -5, which is, it is the easiest way of solving for the sum of solutions in any given quadratic equation. All right. Now, sometimes they will ask you for the product of solutions, which is multiplication of the solutions. So if you have, let's say, solutions uh, A and B, the product is basically A multiplied by B, right? This is a real question that you will be asked usually on the SAT. So if you're asked for that, the easiest way of solving it is the formula is C over A, which is this C divided by A. And indeed, if we tried it out by the previous equation, which was like this, I guess. Yeah, the product might be the multiplication might be will should be -14 because -7 multiplied by 2 is -14. And indeed, if you put it to the formula and divide the c -14 by 1, which is a in here, you will still get -14. So we are proving that to find the product of solutions, you can always use this formula c over a. Guys, did you understand so far what we learned? And if you have, any misconceptions, anything you might not have heard so far, I can explain you them because we are going to go to the important concepts from now on, the harder ones. All clear. All right. Yeah, they are giving examples of sum of solutions, product of solutions, but they are the same thing, all right? We have this example number 5, which is we are gonna skip for later, right? Let's solve for some examples. Example number 6, here I have sent to the channel. Uh, I need you guys to solve it on your own because you have to practice. What is the solution to the given equation? Guys, can you solve it in this equation using tilde and using x1? Desmos, not your mind, not on paper. Just use Desmos to get the 100% correct answer and to get the fastest way of solving it. If you can solve on Desmos, can you send me a screenshot of how you solved it, what way you used it? You solved it through. I guess we have a answer. Right. Why did you put 1 in here? It wasn't 1, I guess. It was x1. Yeah, yeah, yeah. Yeah, no worries. Yeah, no worries. Yeah, this is the correct way. This is the easiest way of solving for this question. So just use x1 instead of x or any other letter other than x and y, and then put tilde here to get the answer directly in here. All right. Uh, Now, these are the ways of solving these questions, but still, these questions are indeed on the SAT, and you will see them on the SAT usually. And then solving them in seconds using this Desmos is very helpful. Solve for this one, guys. Solve for this next one. This is the same thing, but a little bit tricky. Again, tilde and x1. Nothing different from that equation in there. It's just we need to, you guys need to learn when to use Desmos instead of learning how to use it mostly, right? Because knowing when to use Desmos is going to help you a lot and save time. Sometimes you might not be able to use Desmos, and knowing when it is going to happen is helpful. Positive solution 2. All right. What about the negative solution? Negative solution is what value? Negative 9. Right, right. If you have written it correctly, yeah, yeah, it must be right, correct. Yeah, again, right answer. Now, a harder one. Let's look at harder practice and then we can move on to new concepts, all right? This is a harder question. In the xy plane, the graph of this equation passes through the points m and 6m, where m is a positive constant. What is the value of m? Guys, can you solve for this equation? And if you cannot, if you have no, if you cannot, can you give me your thoughts, your ideas of how we can solve it? I think the passes through the point phrase already must tell you to plug in the x and y values to the equation. Right, we got an answer, I guess. I'm not sure, but 2m minus. Did you write the question correctly? Minus 12. All right, but the question tells us that m is a positive constant, not negative. Guys, look at here. It's a positive number, not negative. So we have to find the positive number instead of the negative one. All right, and I'm gonna teach you a trick in here. After you guys try to solve it, we have to tell Desmos that m is a positive number instead of saying it is a negative number. How can we do so, guys? What do you think? Any ideas? Just two, maybe the reverse. No, yeah, no, no, it's not gonna work that way. It's not, it's not a rule or it's not something that works every time. It might work. It might be a coincidence sometimes, but the answer is not two. So let me write that down. Let me show you. When you're given equation and told that it passed through a point, the x value in here, in this case m, is gonna go to the x here, right? To the x in here, and the y value, in this case 6m, is gonna go in here. So we're gonna write down with tilde, of course, 6m equals m squared, right? M squared, just like the student did, plus 2m minus 12, plus 2m minus 12. Now, when we do so, guys, we have a problem. The question tells us that the answer is positive, but we are getting a negative number, right? Positive constant. We have to focus on here. If you write down the answer negative 2, it will be incorrect. The easiest way to tell Desmos that this value m is a positive is by writing like this in next to the, next to the equation. M is greater than 0. And when you do so, Desmos understands that m is greater than 0, meaning a positive number, and it will try to find a positive value for the m, which is in this case, the value is 6, right? This is a trick, guys. You can write down m is less than 0, m is greater than 0. If you write down less than 0, it will show you the negative number. If you write down more than 0, it will show you the positive number, all right? You can do both of them. Uh, just remember this. It will be helpful a lot. This trick itself is going to be helpful a lot, especially when you want to get the positive number and it doesn't show the positive number, just like this case. All right. So far we just learned the simplest basic topics, the concepts. Sorry, and now we have to go on and move to the harder questions, and we need to start from this one. The factors of equations. What is a factor? A factor is a number or a expression that is a expression, let's say, an expression that can be divided without any remains, or what you call them, remains. Yeah. For example, in this example we had in the book here, yeah, in this equation, one of the factors was x plus 7. So if you divide this value by x plus 7, there will be no, what you call it, remains. I don't recall how you call it, but خلدق, we call it in Uzbek, right? There will be no remains if you divide this by this or by this. So these are the factors. Now, one important rule that you must know when working with these questions with this topic is a factor and the expression, you know, this expression, this equation, yeah, equation, let's say an equation, and the equations factor must have the same x-intercepts. X-intercept is when the lines cross this x-axis, right? So the rule is a factor of the equation and the equation itself must always have the same x-intercepts. Now, if you go back to this question right here, it reads one of the factors of this equation is x plus c, where c is a positive constant. What is the smallest possible value of c? Right. So we need to find, we have one factor and we have the equation. Let's write it down. So if you write down 2x cubed, and then plus 2016x plus 2016 216x, we can see equals 0, right? Is that how it is written? No, it's not written that way, but yeah, it doesn't change that much. We can see that there are 3 x-intercepts in this equation, right? And we have the factor x plus c. So x plus c. Yeah. So we have to find value of c. No, not value of c, but smallest possible value of c. And the c must be positive constant. All right. So smallest, not greatest, the smallest one. Now, what we can do here is, knowing that negative 12 is one of the factors, we can equalize to this, or the easiest way is just using the slider here. Click on it and try to find values of c when that factor and the equation have the same x-intercept, or meaning they are crossing the same x line in here at the same point. Here we have c equals 0. It's causing it has the same factor, it has the same x-intercept as the equation, so it is one of the factors. All right, x plus 0 is one of the factors. The first one is x plus 0 or x itself. X plus 0 or x don't make much of a difference. Yeah, x plus 0, right? Now, if we again we have two more x intercepts, right? We can move it again. If we move the slider again like this, when c is equal to 9, we again have a point at which the equation, the purple line and the black line, the factor, have a connection, a place where they touch each other, directly from the x-intercept, x line. And it is when c is equal to 9. So the second factor of this thing is x plus 9, all right? And then if we again move it a little bit farther, the slider, you have one more point right here. And when c is equal to 12, we can see that they are again crossing the same place. So c in here is equal to 12. And the third factor is basically x plus 12, all right? Now, we have found three values of x, which is one of them is 0, the second one is 9, the third one is 12. We need to find the smallest possible value, but the possible value must be positive. If you look at here, the 0 is not positive number, so it is out, alright? 0 is not a positive or negative number. And the smallest value out of these two is 9, so the answer must be 9, 9, alright? So the c must be equal to 9, not 12, because 12 is the greatest value. Again, guys, I'm repeating this. The factor, right, this black line, and the equation must have the same x-intercepts, all right? The same place where they intersect the x-axis, all right? This is the rule. And this is the rule using which you can solve this question on Desmos. This is the easiest way of solving it. If you didn't have Desmos, if you couldn't use slider in here, this thing is called plus slider, you could equalize these things, the negative 12 could be written to here and, on hand and solved for again the same numbers 9, 12, and 0. But still, the answer would be 9. But the easiest way of solving it is just using slider like this and seeing at which point they touch the x-intercept at the same, you know, time. Yeah. Guys, did you understand how to solve it? Did you get it? Did you understand the way, the trick I just used? Because we're gonna see some more examples of this question. And this question in this exact pattern is very repetitive. All right. Now let's see some more such examples, some harder ones if possible. Yeah. Which of the following is a factor of this equation? Now we need to find we have an equation and we need to find that equation's factor. And how do we find it? We can use our mind and solve for them, but just wasting time. Or we could see which one of these have the same x-intercept as the equation. So if we write it down, the equation, let's write it down: 2x squared plus x minus 15. You also have to put 0 in here, equalize it to 0. All right, this is the rule, this is the trick, how it works. Equalize it to 0, and then try out all answers here. So a is x minus 3. A is x minus 3 equals 0 again. You can just not write it if you want. We can see that it doesn't have the same x-intercept. It has different x-intercepts, right? So it's not the answer. The second answer is x plus 5. X plus 5 is, again, let's see. Yeah, x plus 5 also doesn't have the same x-intercept, all right? It has different x-intercepts. right? So it's not the answer. And then we have 2x minus 5, 2x minus 5. So 2x minus 5. But this answer indeed has x-intercept, the same one with the given equation, meaning it is a factor of this whole thing. So the answer is C. Let's try D, 2x plus 3. Again, 2x plus 3 doesn't work because it has different x-intercepts, so it's not the factor of this equation. The only answer that is correct is answer C, right? So this rule that we learned, an equation and the equation's factor must have the same x-intercepts, is the rule using which you can apply Desmos and solve these questions easily under like one. And these questions are, considered hard for the SAT, all right? Let's look at other examples. What is the sum of solutions to the given equation? We have an equation, but the problem is it is not in the standard form. It is not the ax squared plus bx plus c, right? So we have to find, we have to still find the sum of solutions. We cannot use the formula negative b over a that we learned. How can we solve it, guys? How to solve it? Do you know? On Desmos, not on paper. If you want, you can solve on paper, but it takes time, so I would advise to solve it on Desmos. It depends on you and your confidence most of the time. Any ideas, guys? I know that we cannot use the formula, and that's why it might seem hard, but it is very easy, one trick, one concept, one nothing new, but it is possible to solve on Desmos without any trouble. You have a photo here. Let's look at it. Yeah, right. This is the right way. Yeah, yeah, yeah. So what we can do is we can, find the answers on our own from Desmos and add them. So if we write this down, 2x minus 3 squared, equalize it to uh, 4x plus 5, 4x plus 5, we can see two answers, right? Two answers, this and this. And the easiest way is just copying these answers and adding them because the question is asking for the sum of solutions, which is just adding the answers, right? This is the easiest way. So if we add it, we will get the answer 4, which is the correct answer to this question. And there are no lines, no other graphs. So we are sure, we already know that adding these two will yield us the sum of solutions to this equation even without the formula, even if we do not use it, all right? But if you want to use it, you can just open the parentheses and then add, subtract, do something, take some time, and then solve using the formula. But the easiest way, again, is Desmos, all right? Let me send it to the channel again. Next question. Yeah, the other ones are all related to the factor thing. Yeah, which is what we just learned. Let's look at those examples. Now we are in the example, this one. Yeah. One of the factors of 5x cubed minus 5x squared plus 120x is x minus m, where m is a positive constant. What is one possible value of m? Guys, use the same trick I used, right? And try to solve for this question, right? You have this picture here that, how I solved the other question. You can do the same thing without any struggles. Find the one possible, not greatest, not smallest, but any possible positive number of m. And if you want, yeah, It doesn't matter which answer you choose. If there are, I think there are more answers, more possible answers, but any one of them can be the right one. They are both all considered correct. Guys, can you solve it? Are you solving it, or should I give more time, or should I solve it on my own? Yeah, we are getting an answer, I guess. And I hope others should be, would advise everyone to be active like this student here, because if you practice more, you will get, you know, you will increase your score by a lot. So we have the equation, the factor, and m is equal to 6, m is equal to 4, but m is not equal to 0, all right? M is not equal to 0 because we are told the m must be positive, so it is either 4 or 6. It is the right way. It is the correct answer. I hope it was easy to understand the trick. I think there was nothing hard. Let me show you again if you haven't still understood it. So we write down the equation, which is in here 5x cubed minus 50x squared plus 120. 50x squared plus 120. All right. 120x, right? Yeah, yeah. And then we have x minus m, right? Yeah. We can use again the tilde to find the times at which they are intersecting. M is equal to 0 in here, so we do not consider this one. The other ones, when m is equal to 4, right here, we have the answer 4. Yeah. Also, guys, don't look at here. Sometimes they are they are the same number with m, but the answer is not here. The answer is in here when m is equal to this, right? So do not look at here or here. Sometimes they might be same number, but be careful. Look at here. Look at this number in here, inside there. M can be 6 or 4. This is the right answer, and this is fully correct. This is one of the hardest questions in that topic. So solving it that easily will save you a lot of time firstly, and then it will, it's it will earn your points. Next question. In the given equation, k is a positive constant, right? The product of solutions to the given equation is this thing, expression, right? Where w is a constant. What is the value of w? Now, guys, let me ask you a question. In this equation, not the question itself, in this equation, what is c? What is c in here? In this whole equation, not just the thing, not just not the question, but in the equation right here. What is the value of c? K plus 1. Others, what do you think? Think about it for a moment, and then we can decide. All right, what is b? The middle one. Yeah, b is actually this thing in parentheses, right? This thing, whatever it is, 2k plus 1. Yeah, 2k plus 1 is the b. Now, we are told that the product of solutions, basically C over A, yeah, C over A is equal to W K plus 1, right? So if we equalize K plus 1 divided by 4 to the given expression right here, we will get the value of w, right? So let me write it down like this: k plus 1 divided by 4, right? Yeah, is equal to w k plus 1. And when you do it, you can put any value to the k. The w does not change. You can change the k as much as you want. The value of w is always going to stay the same, which is basically 1 over 4. Also, you could solve it on your head. That isn't. It's sorry, there is no problem. It's not that hard. So, knowing that the formula, say c over a, is gonna yield us the product of solutions, we are equalizing the value to the given expression, and we are getting the value of uh, w, which is 1 over 4. Not hard, guys. I guess it is. I think it is really, really easy to solve this question, and this considered hard by the SAT. So if again, know how to use Desmos, you can get 800 without much effort. And next question: in the given equation, P and Q are positive constants. All right. The product of solutions to the given equation is this thing. All right. It is the C over A again, product of solutions, where n is a constant. All right. What is the value of n? All right. Now, guys, a problem we have is we don't have concrete answers. We don't have actual numbers. We have the Q and P right here. The easiest way is putting random values to P and Q because it doesn't make difference. So if you have, you know, uh, yeah, before that, guys, what is the first step? Let me ask you this: what is the first step? If it was on the test, what would you do? What would you do firstly, without before using the formula, before going on to the formula? The you know the tricky part of this question. What do you think it is? Habs Ochish. No, why would you need to solve for this when we are not asked for the sum of solutions. We are asked for the product. We need to work with C and A. If you have noticed, guys, this part right here. Oh, let me draw it. Is not is not equal to 0, right? We have to make this part equal to 0 because it is how it was in the given formula, right? In here we had yeah, 0, right? We always have to have 0. So we have to change, we have to get this to this part. So it will be when we, change their places, when we move it from the right side to the left side, it will be 64p plus 32q equals 0, right? It's how the basic maths. Changing this from this side to this side. And this is 64p plus 32q is the value of C, if you have noticed. Oh, yeah. 64p plus 32q is equal to C. This is the value. Now A is equal to 72. And the product of them, basically C over A, is equal to this number. Let's equalize it. So what was the value? 64p plus 32q divided by 72, right? Is that how was it? Yeah. And it's equal to n 2p plus q equals to n 2p plus q. Right. Now, guys, another problem we have here. When we are doing so, we are not getting any answer, as you can see. We are not getting, it's saying that q is equal to 1, but we do not know it, right? And it's equalizing n equal to 1. Not sure of that. What we can do is we can give random values to the p and q, because if you think logically, giving them values does not change the equation because there are both p and q in the both sides, in the right side and the left side. So if we say p is equal to 10 and q is equal to, let's say, 20, it doesn't make a difference. We could just say 30 or we could just say any number we want. Let's say, let's use slider like here. As you can see, even when we change the q or the p, the n value is not changing, right? So n is equal to what here? 4 over 9. And the value of n is equal to 4 over 9, which is the answer. So what we did was, we realized there is this trick that SAT is using, right? We don't have the zero in the right side. We have to have a zero. We changed their places. We turned this side 0 by just moving this to the left side, and then found C, and then divided by A, and equalize it to the given expression, which is the last parts, and then give, uh, random values for P and Q. But even if you do not give the values, it still shows you the right answer, right? It's still the same answer, 4 over 9. I just put random values to assure you that even if the P and Q are different values other than 1, they are gonna stay the same. The N is gonna stay the same, alright? You can say P is equal to some kind of crazy number like this, and Q is equal to another crazy number like this. The N is not gonna change. It is the rule, alright? So the value of N, the answer to this question is 4 over 9. Understood, guys? Did you get how we solved it? Or is there any misconceptions you have right now? Got it? I think, and it's not that hard if you just, can correctly use the formula. Let's go on to the last example practice. Let's see it. In the given equation, p is a positive constant. All right. The solutions to the given equations are integers. Right. Integer means a whole number, not 1.2, 1, 2, 3, such values, not a point or portion, something like this. Which of the following is are possible values of p? Guys, how can we solve it? What do you think? How can we solve it? What is a trick we can use? What do you think? What are your ideas? Any ideas, thoughts about it? Okay, the lines. Yeah, it is uh, correct, but yeah. I think I understand what you mean. Try that out and try to answer the question using decimals. This question can be solved under 1 minute. All right, 1 minute. That's all. Even 30 seconds you can do if you type fast on decimals. I guess it is a question that seems hard, seems very hard, but it is something easy to solve. And if you need more time, I can give you more time. And if you cannot solve it, you can tell me, I can solve it for you and show it the easiest way. Also, the questions won't get harder than this, I think. The equations things are not gonna get harder than this, I believe so. I haven't seen a hard question on this topic in a long time. I am done. Can you show me the picture of how you solved it, or if it is possible? Or you can tell there is no way. All right, all right, all right. Let me show you the easiest way. The first thing you're gonna write this whole thing down. X squared plus px plus 18 equals 0, right? But we have p, so we cannot look at the graphs. And we know that when we put one of these values to the p, the solution, the solutions must be integers. So let's try out those answers, those numbers. If we put 9 instead of p, the answers are integer and integer. Both are integer, right? So it is a right answer, right? Because the solutions are integers. This is what the question is saying. And if we put 17, we can here look at here that the answers are not integers. They are 1 point something something, 15 point something. So they are not. So this is not the right value. 17 cannot be the answer. Only 9 can be. Let's try out the last one, 19. Let's try out 19. If we put 19, the answer solutions are again integers. So 19 also works, right? So 9 and 19 works. When we put 9 and 19 to the p, we are getting integers as the answers. So the answer must be 1 and 3, which is answer choice C, right? Did you understand it, guys? It was, I think, really easy to solve this. Let me change these colors: blue, red. Let's do it. Let's do something like here. 9. It can be 17. Yeah, here we have all of them. Yeah. Did you guys understand it? Just putting the values to the p and trying and seeing and watching which one has solutions that are indeed integers and which ones doesn't. 19 and 9 had integer answers, not an integer. Did you get it, guys? If you didn't, I can explain it again, but you just need to tell me right now. Yeah, they are also explaining the same with factors and their equations. Yeah, yeah. They must have the same factor at the same place. Yeah, it is same thing. Now, guys, understand it. I think as I'm responding, I hope you all understood it. It is just trying out the values for p and seeing if they are integers. The solutions are integers. If the values of the p fit the criteria given in here. The solutions to the given equation are integers, all right? So this is the criteria we are using. Now, guys, so far we have learned the equations, right? The equations only. Because topic was, quadratic equations, not uh, equations. Yeah, quadratic equations. But the other part of this quadratic thing is the quadratic functions. And the graphs is gonna be learned in the topic quadratic functions. Their graphs, how they work. Because if you try out a function, a equation, it will show you this parabola. It has its own vertex. It has these points. There are a lot of concepts that are associated with it. We need to learn, yeah. But this is for the next lesson, in which we will learn the whole graphs. Right now, we just learned the equation itself, and the next topic is gonna be about the graphs of it. But to learn the graphs, but to master them, you have to master the equations itself first. All right. So I'm gonna give you a bunch of homework in here. from this two books. I guess it will be not that much. Not that much. Where was it? That's hard book. Yeah, this one. It's, no, not this one. This one is too hard yet. Where was it? I will give you guys homework to practice and master this whole topic. All right. And this topic was not that hard, I guess. Just some bunch of Desmos tricks. Where are the files here? Yeah. These questions here are all from the real exams, all right? From real exam questions, all of them. Uh, you should go in here. Topic was quadratic equations, right? Exponential functions. Yeah, quadratics here. The page 203. Here we go. Yeah, these questions. We should solve all of them, as many as possible, as many as you can, all right? Some of them have these graphs. You don't need to solve those because they are not covered yet. The graphs are the only part left. But solve as many as you can until until you run out of questions, all right? We have how many questions here? We have too many. All right, solve 50 of them, all right, 50, from 1 to 50. And if there are any questions that you might not know, you might understand, send them to the group. I will explain them, or anybody that can solve it might explain, all right, from the students. Send them to the group. Solve 50 of these questions, and then you will go on to the College Panda book, right? I have sent it in the group, in here, yeah. Yeah, the same book. And open the page, yeah, open this 12th, yeah, topic, and then start from exercise 1 in here, all the way down till you solve all the questions, not even one left, all right? Because these are the questions we solved together, and the questions are not that hard. They are easy to solve and understand. Solve all of them, and send me the pictures, the Desmos ways of solving them, all of solving them to here, right? To this group here with your name. Name is not important because I can see your chat, but you should send them with the number of right answers and the number of wrong answers. So if you have, let's say, 100 questions solved, you should write 78 out of 100, and then send me the and send all the right answers separately from the incorrect answers. All right, they should be separated because we're gonna look through all of them, all of the incorrect answers. So guys, any questions about the topic? This was, I guess, a hard topic that was simplified on using Desmos. Any questions? Any misconceptions? Yeah, let me show you again. From page, what page was it? I can see it here. From page 139, I guess. Yeah, in this topic 12, we have homework. The book itself has homework. Here, starting from this till we finish it, till the 13th topic. And from this math book in here, you will go on to the topics given in here. Press this quadratics, right? Advanced math quadratics, and start solving 50 of the questions. The first 50 questions, all right? All of them, 50 questions. And if you cannot solve, you can send it to the channel. You can work with AIs. You can do as much as you want. Uh, and I think doing those will help you already master the full, this topic. And then we can move on to the graphs, work with them. They are also not that hard. They can be solved using Desmos. This topic itself is important and hard, but Desmos is going to help us a lot. So next thing we are going to learn is quadratic functions, their transformations, how they transform, how they change. And then after a couple of topics like inequalities, equations again, we can move on to geometry and statistics, I guess. Also, guys, have you covered percents? Have you covered percents and lines from these, June, from these lessons that I've sent? Where was it? Yeah, here. Have you watched the lessons in here? And I covered lines. All right. And did you understand everything on this topic? Or is there any questions? If you have any questions about, anything you have watched, any questions about the whole math, you can ask me now because it is, we need to really uh, cover the left out topics on those from those videos. All right, guys, if you have no more questions, we can end the lesson. Thank you for joining. And the next lesson is going to be on Saturday, the same time, 20 p.m. All right, and we're going to do a lot of practices because we're going to be finishing this whole topic, quadratics. Right? Thank you for joining. If you have any questions, you can send it to the group, my chat or group, doesn't matter. Thank you all too.